Okay, so here is the chapter test in the limits introduction. From the limits unit of the Introduction to Calculus textbook. So this is section 1.9, and I apologize already for this being a little bit blurry, but I hope you can make it out. So the first one, we're taking a look at the limit as x tends towards 2. There's a 2 here. And we have x squared minus 5 over x minus 1 all under the root sign. So in this case, we want to just directly plug in. We don't need to do anything extra. So we'd have 2 squared plus 5 over 2 minus 1, and this is all under the root sign. And so then if we add the numerator, we get 9, the denominator is 1, again all over the root sign, under the root sign, and then your answer is 3. So the limit as x tends towards 2 is going to equal 3. In the next one, we have just a little bit more work here. We are looking as our limit tends towards -1. We don't want to directly plug in because everything's going to equal 0, but what we can do here is factor. So you still have x plus 1 in the numerator, then the denominator will factor to x minus 5 times x plus 1. Then we'll see that we have our x plus 1s being canceled out, and we're left with 1 over x minus 5. And now we can plug in that limit, so 1 over -1 minus 5, and that will give you -1 over 6. So the limit as x tends towards -1 is -1 over 6. Now this last one, you are plugging in when your limit is x tending towards 1. The problem with this one is more the math involved gets a little bit more complicated. So we can't directly plug in the 1 because if you see in the denominator, it will go to 0. So we need things to cancel out here. So the first thing we can do is look at the numerator. And if this was all over 1, we can, meaning which it is, which is our fraction. Your common denominator is the root of x. And then we can do the subtraction. So the first part would just be 1, and then the second part would be root x. So I'm just subtracting my two fractions. So that's what we're getting in the numerator. And then in the denominator, I have x minus 1. But what I'm going to do here is just put this over 1, and then hopefully seeing that it's division, I can multiply by the reciprocal. So I'm going to multiply by 1 over x minus 1. So now this is no longer here in the denominator. Now that I have that, I can see that, what am I going to do here? 1 over root x minus 1. Oh, and now I'm going to multiply through. So I would get 1 minus the root x over the root of x times x minus 1. Now that I'm at this point, I can see that this here is a difference of squares, and I can expand this further. So this will end up being, so the 1 minus root x is still there, the root x is still here, but then with our difference of squares, if I take the root of x, it will just be the root of x. And then if I take that -1 and root it, I'll have -1 and +1. Now I'm almost there, but not quite, because I need my root x to be negative. So the last thing I can do is take a look at, which one do I want here? This first one here. This first binomial, I'm going to also factor out a -1. So I'll have 1 minus the root of x over, I'm taking out a negative, root x is still there, I'm taking it out of this one, so that will end up being 1 minus root x times root x plus 1. So now I can see that my factor on the top will cancel with 1 on the bottom. I'm just going to come over here for space. So I would have this all equal 1 over root x times, this is negative, root x plus 1. Now I can plug in my 1. And when I do plug that in, I'll end up with 1 over 2. And this is all negative because my negative sign was still there. So when I'm plugging it in, taking a look at my limit as x tends towards 1, and with this math that is a little bit more complicated, you'd end up with -1 over 2. Now this next one, we're taking a look at our points P and Q, and they lie on a parabola. Then they want us to find the slope of the secant line. So if we're looking at the secant line, that is looking at the line going between P and Q. So I'm just going to do that one first. So A here, if I want slope, it's going to be y2 minus y1 over x2 minus x1. So let's just plug in those values. So -4 minus -1 over x2, so 3 minus 2. We plug that all into our calculator and we get -3. So that's the slope of the line that's connecting P to Q. Part B is asking for the slope of the tangent line at point P. If it's the slope of the tangent line, then we have to use our formula. And our formula is the one where we have y, or your slope, is going to equal the function of x minus h minus the function at x all over h, and this would be as our limit of h tends towards 0. So we want that slope, that x value on the bottom, to have a very, very small value. So because it's looking at point P, and point P is 2 and -1, this will be our x value, and this will be our f of x value. But then the next point we're looking at is still 2, but we're going to subtract h. We want this value to be very, very small, tending towards 0. So when we fill this in, our first point, f of x minus h, we can put that into the formula, is going to equal f, or not f, sorry, not that. It's going to equal negative, and we can, x value is 2, so 2 minus h squared plus 2 times 2 minus h minus 1. And then we still have subtract f of x. F of x is -1, and this is all over h. So we're going to expand everything out, cancel what we can. So -1 minus -1, that equals 0, so we can get rid of that. Oh, it doesn't all want to cancel here. There we go. And this side here, we can expand out. You do have a negative out front, so 2 minus h squared will end up being 4 plus 4h plus h squared. And then we have 2 times 2 minus h will be plus 4 minus 2h all over h. And then we did all of that work, and when we start to drop our brackets, we'll see that the 4 value will go away. This will end up being negative. This will end up being negative. And then we can simplify it a little bit more. So that will work out to -2h minus h squared all over h. We can factor out an h on the numerator. Then you're left with -2 minus h all over h. H's cancel. Now we can plug in that limit of 0, and that will go away. And then the slope of the tangent line will equal 2 at point P. So lots of work there. Now that we've done that, if they want the equation of the tangent line at point P, so the tangent line has the point 2 and -1, and it has the slope of 2. So we can just use point slope form and plug in those points. So y minus -1 will equal your slope times x minus 2. So minus x1. We have that, and plug in and expand. We will have y plus 1 equals negative, wait a minute. Oh, wait, was my slope? Sorry, I'm missing that. My slope was -2. So this should be a -2. So then we'll have -2x plus 4. And we want to move everything to one side, making that x positive. You get 2x plus y minus 3 all equals 0. So that's our answer for C. And then the last one, graphing it out. If I were to graph it, and I won't do it too detailed just because I don't have my graphing calculator, but if you were to graph it, you would have your parabola, and it would be opening downwards, and it would be shifted a little bit. On your parabola, you would have 2 points. When you join those 2 points, that would be your secant line. And then if I had this as my point P and this is as my point Q and drew in my tangent line, that would be the line I just calculated. So that's all the work for number 2, which gets a little bit messy, but hopefully you get the idea. And then this next one is starting to look at piecewise functions. So we have the first part that f of x will equal 1 minus x squared if x is less than or equal to 0, and it will equal 2x minus 1 if x is greater than 0. So when we take a look at this, if you approach f of x from the left, that would mean you're less than 0, so we're going to use that first function. So if I look at a and use that first one, I would have 1 minus 0, and my value would just be 1. If I look at b, I have to use that second function coming in from the right because that would be a bit greater than 0, and then I get negative 1. So the fact that these numbers are different, when I'm looking at the limit of 0 exactly, it does not exist because coming in from the left and coming in from the right is giving you different values. So if we were to sketch this graph, you would see just like a quick sketch. If it was 1 minus x squared, that is going to be essentially half of a parabola. So we're going down this way. And then the 2x minus 1 is going to be a line that looks something like this. And then we would see that this point doesn't actually exist. And when it's asking that point of discontinuity in C of the question, that is going to be when x equals 0. Because we're seeing that big jump between values when x is 0. Moving on to number 4, and I'm sorry for how messy this is, but we can still get there. This one's asking about displacement, giving us a formula, and your formula is s equals 5t squared minus 6t plus 14, and t's in seconds. So the first one's asking for your average velocity. So we'll just need a few values first. So when you're looking at your function, we want to figure out s of 2 for the 2 seconds. So plug it in 2 every time you see a t. So 5 times 2 squared minus 6 times 2 plus 14 is going to give you 22. Then we need to figure out s of 3, so the y value at that point. So plugging in 3 every time you see a t, and you'll get out 41. So if we're looking at the velocity or average velocity, we just need the slope between those 2 points. So we'll do the y values, 41 minus 22, over the x values, 3 minus 1, and you get the slope of this function is 19. So that is between that interval, but if it's asking for an instantaneous velocity, then instead we want to find the slope using the formula f of x plus h minus f of x all over h as your limit of h tends towards 0. So making this interval, instead of being 1, making it close to 0, and that's why we're making that h value go close to 0. So we're going to start by plugging this in, and by doing that we will have the limit of x plus h going in for t, so 5 times x is going to be 2. 2 plus h squared minus 6 times 2 plus h plus 14. And then we're going to subtract f of x, and f of x is 22, so minus 22, and this is all over h. So we're going to simplify what we can. So if we expand everything out, so we'll have this first one, 5 times, this ends up being 4 plus 4h plus h squared over, distributing that through, negative 12 plus, not plus, minus 6h plus 14 minus 22 all over h. So we're going to distribute that 5 also through the brackets, and we end up with 20 plus 20h plus 5h squared minus 12 minus 6h plus 14 minus 22 all over h. Collect like terms, coming over here, and we end up with 14h minus 5h squared all over h. Let's factor out an h in the numerator. So you have 14 minus 5h over h. The h's cancel. You can plug in your limit of 0 now. And if this was 0, you get the slope equaling 14. And the slope represents velocity. So the velocity instantaneously when the time is 2 is going to be 14. Moving on. This one is just says evaluate. So we have 1 over 8 to the power of n plus 6n minus 2 over 2n minus 3. So with this one, what we're going to do is realize that if you plug in n to equal infinity, then this is one of those that if this number is going towards infinity, the denominator is getting bigger and bigger, and this whole thing tends towards 0. So we can take that away. Then we have 6n minus 2 over 2n minus 3. Then the hint here is to divide everything by your highest exponent, which is n to the power 1. So we'll have 6n divided by n minus 2 divided by n all over 2n divided by n minus 3 over n. Now, if you again plug in that limit as n tends towards infinity, these numbers will tend towards 0, and the first terms of each, the numerator and the denominator, the ends cancel. So you just get 6 over 2, and this whole thing simplifies to just 3. Now our very last question is about a sum of the series. If we want to calculate the sum, we're going to use our formula a, so your first term, divided by 1 minus r. So I need to figure out first if this is a series, which it is. So you can take your your second term divided by your first term, and you'll find out that your r value is negative 3 over 4, and your first term's 12. So we're just plugging this directly in. You're going to have 12 divided by 1 minus negative 3 over 4, and you plug this all into your calculator, and you'll see your sum is 48 over 7. So that, I believe, was our last one. So thank you for watching. I hope you find that helpful. I will be starting the next unit shortly. And if you are also taking chemistry, if it's in Alberta, Chemistry 30, please check out my channel for videos on all topics. Thanks for watching.